Machine learning, which is a very vast topic. It's like an ocean. But I would like to confine myself only to how could I use machine learning for practical purposes like research? And does it motivate you to incorporate it in your own research work or otherwise? So, to start with, this talk will not give you a PhD. I assure you that. But certainly, many of you could use it to get a PhD. Secondly, this talk will not deal with statistics behind machine learning. Because if you go to the internet and look at Google for machine learning, it's filled up with so much of mathematics and statistics. I would like to take few machine learning practical techniques and demonstrate it to you using a popular open source tool called WEKA. And thirdly, I hope that this talk will open avenues to pursue further research and to expand on your current understanding of machine learning. With this word said, I would like to introduce you some of the latest machine learning applications which brought a lot of interest to me. This is something that's happened in 2011. The company called NEC Japan has come up with a facial recognition system. And you know, when a person stands right in front of the camera, it can even estimate the age, gender, and even race, whether you're Asian, Caucasian, or Western. So, that ability is built in these facial recognition systems. And what is it meant for? When I get this information, I can have what you call as advertisements which are driven by the profile of the people who have their faces recorded. In this connection, I would like to just mention the Japanese East Railway system has lately introduced vending machines for drinking. Different types of drinks are there for customers. And what it has is, it has a camera. The moment you come near to the vending machine, it takes your profile and then it suggests you the drinks for that particular profile. And more than that, it's nothing but a machine learning system. This camera records what you are choosing, what it has displayed, what you've chosen, and it keeps on learning, making itself better and better day by day. Another interesting application I found is this bowling ball. Talkara Tomy is another big company in Japan. Their product, simple. It can translate dog language into human language. All you need is a wireless belt around the dog's neck. And then all you need is a small device in your hand. And the moment your dog makes sound, any noise, that's translated into language or emoticons. So that will tell you whether your dog is happy, sad, hungry, angry, and whatnot. So these are some of the current applications which I thought was interesting in machine learning. But more than that is, I was also surprised. If you look into Google, you'll be surprised to see it's almost in every diversified area of learning that you have find machine learning incorporated. One thing very interesting in 2011 was the New York City Power Grid Maintenance Department has incorporated machine learning, which has drastically reduced their costs with an aging power grid in a city like New York. Now what you can do is, it tells you, it can identify potential problems of areas, and so also you could do preventive maintenance. One machine learning application is an IEEE paper which came in 2011 by an electrical engineer. Electrical engineering using machine learning. Another thing I just recently read, another nice paper, Walk Safe. Normally most accidents in cities happen as you cross streets. So if you take any mobile phone, you know there is a camera at the back of it. So normally passerbys, when you cross the road, you always talk like this and cross, and then you will never see a speeding car coming and then hitting you. So what WalkSafe is nothing but an Android-based application that has been built using machine language, and it can distinguish between the front and the back of a car. And more than that, it can also distinguish between an approaching and receding car. So the front, threatening, if it's approaching closer, it's definitely a threat, and it gives an alarm to the user saying, okay, there's a car coming, and take precautions as you're talking. So, what's machine learning? What is it built of? It's not built of just two. There are many different branches. It's psychology is involved, philosophy is involved, neurosciences is involved. But there are two major things. Let me make it simplified. There are two major parts of it. One is computer science and statistics. Why computer science? Computer science helps you to manually write programs for these computer systems. And statistics is that which helps you discover what is inside the data. So the two of it together will help you build machine learning. So what's machine learning? Machine learning is nothing but defined as how do you teach a computer to do a specific task. And all what you're given is to the computer is several examples of the task. So they can learn, generalize, and now start working on specifics. So why machine learning? You don't have to write the algorithms, and you don't have to build those software tools because they're all available. Abundant number of algorithms in machine learning and several software tools, both in the open source as well as customized, proprietary. Growing abundance of data. We are actually drowning in data. That was what a famous writer told. Today we are drowning in data. It's not just characters and text. We're drowning in data with video, audio. It's all multimedia. Enormous amount of data. And most researchers are also flooded with data. What do you do with this data? If I get few pieces of data, I don't need anything to help me. I could look at it as a human and make deductions as to what is there in the data. But if I have millions and billions of data, what do? You need somebody to help. And that's where machine learning comes to. Increase in cheap computational power. This simple mobile device right in my hand is much more powerful than those $1 million giant computer systems of the 50s. Computational power has come into hand. It's available, dirt cheap. So this laptop has a lot of machine learning programs. I do agree that machine learning programs are computationally very intensive. But right now we have computer systems that can tackle it. Lastly, successful applications, not only on the commercial side, not only in the industry side, but tremendously in the research side. And I want to really say that there are a few papers even in this conference that are related directly or indirectly to machine learning. And I was surprised when I heard once in a presentation that more than 65% of research papers that come out of India are related one way or other in machine learning. So I thought this talk might be relevant to you, irrespective of whether you are from the computer science branch or otherwise. So, humans versus machines. If I had a letter G, I could present the letter G in different forms, right? I mean, if I, as human beings, just a few of them is good enough for us to then deduct whether a given letter is G or not. So when I have a large amount of G's, and when I submit it to a machine like this, it tries to extract features. The machine learning algorithm tries to extract features out of this whole lot, and it tries to generalize. And it helps you to identify whether a given font letter is G or not. So there's a little difference. So that also points to the point that there are no absolute good machine learning algorithms. They have not been devised so far which are 100% correct. We're getting better day by day. But certainly, we have not been able to replace the human intelligence so far. I just wanted to show one more picture before I go into further details. Machine learning simplified graphically. You have a lot of data. We call it training data. I told you examples. A lot of examples. And then I give it to a system which has typically a computer system where I have a learning algorithm. An algorithm is built, a program is built within this computer system which will learn from the training data. So what happens? I get a trained machine. Once it learns the data, I get a trained machine. And ultimately, you throw a query at this, the right query at the trained machine, it gives you answer.